Good afternoon, everybody. I've just put the abstract of my session on screen so you can be sure you're in the right session, or not, so you've got time to leave. What I'm going to be talking about today is deploying your data infrastructure. Not by hand, but by code. Before we start the session, there are a few things I want to mention. The first one is, at the end of the session and during the session, I'll give you a QR code. This will lead you to my GitHub repository, and there you can get all the code that you're going to see today. The code is delivered as is, without any form of warranty. So if there's a mistake in there and there's a problem, it's not on me, please. Or your company. With all the code you download from the internet, always keep in the back of your mind to check it, read through it, and only then run it. There can be mistakes in there, maybe things that are blocking with maybe your company tenant or whatever. So make sure you read through it before you run it. As this is a data infrastructure deployment, please validate everything before you add any kind of data to it. Last thing I want to hear from you is, yeah, we had a data leak, and then there was your code. I don't want that. And it's not production grade as it is right now. This code is meant to give you a flying start into deploying code with deploying infrastructure with code, but it's not all that done yet. But you can have a lot of fun with it. When we're talking about infrastructure, one of the most important parts of it is security. So I went online and tried to find some numbers, and this is the first one I found. Over 1,000 security incidents in 2022, with 480 million and a little bit breached records. That is a lot. I know there's a lot of more data available online and offline, but all this leaking data is something we need to keep in the back of our mind. It's not just England. In the Netherlands, we had about 21,000 data leaks in 2022. In the last 5 years, 114,000 data leaks were reported. Again, it is a lot of data that's being leaked. Just because somewhere security failed, maybe a leaked password, something else, or just something configured wrongly in the security. So this is what any security officer will tell you. Stay out of these statistics. A large part of my session will refer to this one. Make sure your deployment is secure. All right. My name is Rijtse Eskens. I'm working for a company in the Netherlands called Axians. I'm doing a lot of stuff online and offline, like presenting in sessions like this. And because I've done enough of that stuff, Microsoft awarded me the MVP award this January. I'm really happy about that. I'm teaching classes, and my company uses me both as an architect, a developer, or an Azure administrator, depending on the client I'm working with, which is cool, because it keeps my work challenging and changing all around. You can find me online. Links are here. Please find me if you need any help. All right, so let's start our journey. Suppose management has had the most brilliant idea. Thought, we're going to move to the cloud, everything. Brilliant. You're the consultant, make it work. Without any guidelines, without anything else, then we've heard at school, Microsoft told us it's the best solution you can find, do it. You've heard the stories. So there are a few steps I think you need to go through. And these steps are the first things we're going to go through in this presentation. So we need to architect for security. Which means it's more than just resource security, more than user security, and you need to assume a few things. So let's dig into these first. When I'm talking it's more than resource security, the first thing I always like to do is to create policies. Policies will help me enforce rules I want to have on my tenants. They will make sure people don't do things I don't want them to do. And it doesn't always have to do with security. Think about the Synapse dedicated SQL pools. If you're deploying one, it's all nice and easy. Just click, click, next, next, finish, done. At the end of the month, somebody will come up to you and ask you, what did you do? Because dedicated SQL pools can be expensive. And you don't want that. I can create a policy, and I did for my company tenant, that just says you're not allowed to create a dedicated SQL pool. If somebody needs one, they can do a correct motivation, why they need one, what's the use case, what SQ, whatever they need. And then I can create an exemption, which means I'm in control of my environment. Microsoft Azure gives you a lot of standard policies to start with. But you can create your own, almost limitless. So you need to think, what are my business rules? What do I want to secure? What do I want to do with them? Another thing about security is, oops, I should not have pressed that delete button. Question, how many of you have pressed the delete button or executed the delete command by accident? I know. It happens to the most of us. If you can repair it, it's okay. It's even better if you can prevent it. I think somebody is laughing because it was unable to restore it. War stories, different session. I can add delete logs to all my resources, making sure no user can delete something. They can click on delete, the button is still active, you still get all these context menus. Do you really want to delete it? Are you sure? And you click yes, and then it says there's a delete log in place, you can't delete it. As long as this user doesn't have the permission to remove the delete log, you're good. If you're like me and you're the global admin, you can remove the delete log and still make mistakes. But there's an extra step involved, so you need to do more work to delete stuff. Architecture for security is also more than just your standard user security. This should be an open door. Everybody should have 2FA, MFA, whatever enabled. If you're just using username, password, you're just waiting for people, come on in, get my data. That's not what you want. Another trick you can do is enable just-in-time access. This is especially handy for virtual machines, where the standard RDP port is closed until somebody wants to use it and has the permission to use it. At that point, the port opens, you can go in, do your RDP work, the port closes behind you. It doesn't break your connection, but anybody else who wants to connect to that VM won't see that port, the RDP port is open, which is quite handy. This is another one. Enable privileged identity management, especially for people who have elevated permissions, who do stuff on security, who do stuff with the global admin role. Make sure that every time they have to do that kind of work, they send in a request. Hi, I'm Reite. I want to do some stuff on this subscription, and I need to be elevated to global admin. One of my coworkers says, why? Or if I get a brilliant idea at 3 o'clock in the morning, I can send in the request and nobody will reply, and I won't be able to do it. As long as I'm not approved, I'm still a general user, standard user, no extra permissions. Finally, educate your key users. These are the people who are close to your data, who usually have some elevated permissions within the database, within the data environment, if you're using Data Factory, Synapse, whatever. Educate them. You're working with data. There can be issues with security. Please be careful. Finally, enforce the usage of tools like Key Vault. Don't give them, this is the connection string to this database. Don't give them, this is the password for VM X. Give them the password for database Y. store it in the key vault, let them retrieve secrets from the key vault without giving them access to the key vault. So they can just get the secrets they need for their job without getting direct access to all the sensitive data. You need to assume breach. In other words, you need to assume that you have been breached, that somebody is in your system. What are you going to do to mitigate it? What are you going to do to find out what happened? We had an issue a few years ago with a client who who suffered from SQL injection, and we had to find out what the SQL injection had done. What had happened? Did they get any data? Did they get in at all? Because the detection went off, we've seen SQL injection. Every query was logged into a log analytics workspace. So we dug into the log analytics workspace, retrieved all the queries that had been executed by that malicious actor, and could find, yes, he got the database structure, so he knew all the tables, he knew all the columns, but he was using the wrong schema. So he tried to execute against the wrong schema and never got anything back, which was quite lucky because there was PII information in their database. If they had succeeded, that company would have had a huge problem. But make sure you've got these tools in place to find out how can I see what has happened. Hackers are always scanning for a lot of open ports. 3389, the most used one, RDP, you can change it to another port. They will find it in milliseconds. It doesn't matter, they're just scanning for the protocol. So make sure you close down everything you don't need. Always deny traffic, zero trust. You want access to a resource? All right, what is your local IP address? No ranges, one address. Keep it as narrow as possible. And finally, when you're reading through the well-architected framework and the cloud adoption framework, if you apply everything, in the end, everything is mega secure because you don't have access anymore. And it's the most safe way to store data. Nobody gets access until somebody wants to run a report in tools like Power BI or Fabric. And then you need to open up some stuff. Keep it to a minimum. All right. So, question.
Another way to review or to see that is there is no perimeter, because a lot of on-prem always think we've got a nice big firewall.
Can you keep the mic from
yeah, we've got our big nice firewall, nobody's going to get in, but when you go to the cloud, you have to forget there is no firewall, no one big firewall, everything's kind of open to the cloud, so always lock everything down.
Essentially, yes. It's all open, and you need to close everything down. Until a year ago, when you deployed an Azure storage account, public access was by default enabled. So anybody could just walk into your storage account and find out, what kind of containers are there? Ooh, I like that one. They changed that, luckily, so it's now disabled by default, but you can still do it. You can still open your storage account for everybody and anybody. But let's get into the infrastructure as code stuff. So first of all, what is it? For me, it's the easiest way to deploy resources in the cloud. Because I can type all my work, I can type all the stuff I need, and then it just happens. Instead of logging into the Azure portal, click, 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 mistake, back, click, 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 miss something. Maybe there's still a mistake in the code, but I can fix it once, and I can keep running it. That makes my life a lot easier. Also, if I run the code, and I run the code again, and I run the code again, I get the same output. Maybe I'm using variables to change small things, but as long as all those things are stable, I'm getting the same result. I can configure them as parameters, but you need to know something. There are two kinds of code. The first one is the imperative one. And the imperative one, You need to script every single detail. I want a virtual machine. I'm going to script all the single small details, everything I need to know. So you need to work towards your goal, like a chess player. I'm going to move this pawn, I'm going to move the king, I'm going to move the rook, whatever. It's all step by step by step. PowerShell is one example of imperative deployment of infrastructure. It works, no doubt about it. It works fine. Thing is, it takes a lot of work. What I like is this. Make it so. I'm just defining the outcome. I want a virtual machine and it must look like this. I want this version of Windows on it. It needs to have a disk. Done. And I'm just clicking run on the code, and I've got everything I need. I don't have to worry about the specific types of code, about versions of APIs, anything. I'm just declaring the code, and I'm done. Bicep sort of, kind of is declarative. Thing is, with Bicep is you need to define the version of the API, and the API version changes a lot. And depending on what you want to achieve, you need a different version of the API. Because in some versions, this part works, in some versions, that part works. It's hard. Terraform abstracts that away for you as well. You can just type in what you need, run the code, and you're done. If you like headaches, you can write ARM templates. Personally, I despise them. It's so incredibly hard to read, and stuff around it, it's not my favorite. You can use the Azure PowerShell commandlets. It's a kind of imperative way to deploy your stuff, but it works. You need to keep up with all the stuff, and for those of you who have been working with Active Directory in Azure, everything broke when Microsoft thought, you know what? Azure AD? No. Entra AD, much cooler. Not cool, especially not if you're using PowerShell, because everything broke in the back end. You can use Bicep if you want everything Microsoft, which is cool. It's not my personal preference. One reason is that when we started doing infrastructure as code at my company, Bicep was in 0.1 version. It worked, and that was about it. Half of all the stuff we needed wasn't in the code yet. So we went into Terraform, which was miles and miles ahead of Bicep, and just worked. Of course, there were little bugs, things that didn't work exactly as expected. But when 98% of my work is already done, and I need to do the final configuration in the Azure portal, I'm fine with that. Just a few little steps. You can use Terragon, Pulumi, other languages as well, just whatever you prefer. One of the best things about working with code is you can integrate it with DevOps and GitHub. These are code repositories where you can do code versioning, see what changed during all your development stuff. But also, I'm breaking my own story here. You can also do pull requests. Well, I may be thinking, I've got a brilliant way to deploy this virtual machine. Please, coworker, accept this. And my coworker says, well, maybe this isn't the best idea. So you get 4 eyes before things get deployed, promoted to productions. People can review your code, iron out mistakes, whatever. DevOps has quite nice Kanban boards if you like a Scrum way of working. GitHub kind of, sort of has that, but not really. So I'm not sure what Microsoft is trying to achieve with having both Azure DevOps and GitHub. I think they're going to move everything into GitHub, but I'm not sure what they're going to do with the DevOps stuff, because a lot of people are on DevOps. My personal preference is to move everything to GitHub, as the pipelines to do all the heavy lifting are way easier than Azure DevOps. But again, it's a personal preference. I can see some nodding, so I'm not the only one. GitHub Actions, they're brilliant. All right. Now the demos I'm going to show you with all the code, they're created in Terraform and I'm using PowerShell as a kind of support act. I've simplified the example enormously, but when you start using PowerShell to help you, it will make your life even more easy, much easier. Terraform, it's not better or worse than Bicep, but it's just different. Oh. And I did not include any DevOps stuff. I think I'm going to overload you with a lot of code, so adding DevOps stuff would only complicate things. So we're going to build our solution, which means I'm going to begin at the top. Always build bottom up with networking, but I'm going to start at the top. I'm going to start with my management groups. Logical groups of where I'm going to define my landing zones, functional stuff, whatever you want. If you're looking in the well-architected framework and the cloud adoption framework, you can find all the guidelines for management group definitions and what you want to do with them. These are the places where I'm defining my policies. Because for my human resources, I might need other policies than for my... I'm stuck on a word, I'm sorry. Let's get for administration, for instance. General administration. Or for the factory, I might need, again, different policies. So I can split these out easily. That's what I'm always doing on the management group. Also, on the management group, it's the highest level where I can set permissions, if people can have access to all the underlying subscriptions or not. I like it. The higher it is, the less people can see. It makes it easier for my end users as well. So, for example, I can restrict my VM sizes. Maybe some of you heard about it last year from Microsoft. There were some hackers active who tried to hack in Azure tenants, not to steal data, but to create huge VMs. The ones that will set you back $100,000 each month. Why did they do that? To mine Bitcoin. Because mining Bitcoin is quite expensive nowadays. But if you get somebody else to do it for you, that's easy. So restrict your VM sizes to everything you need. In my case, I'm usually only allowing West Europe because my company wants all the data in West Europe, meaning in the Netherlands. Most of the data can't leave the country borders. So when defining West Europe, it's all there. So when I'm going from my management group, I can dig down into one or more subscriptions, one or more resource groups, and within my resource group, I can have one or more resources. Remember that permissions are inherited. So if I'm going to give somebody reader on a management group, it also has reader on the underlying subscriptions, all of them, the underlying resource groups, and the underlying resources. Think about that one. It's a one-to-many relationship, as I told you. Then we're going to deploy my network. This is the hard part, because you need to think about your network. If you have a local virtual network that you're going to connect with a VPN connection, you need to think about the network range. Because if they start to overlap, funny things will happen. Or not funny things, depending on what the outcome is. So you need to think about something called the CIDR range. Talk to the network people inside the company who know what they're talking about. All right, which range can I use or can't I use? Document it as well. Because I've had an instance where we deployed networking and there was a discussion afterwards, you deployed the wrong range. I said, no, here's an email. This was what I was supposed to deploy. Document it. Subnets matter. Why? Well, there are a number of subnets that need to have a fixed name. The VPN gateway needs a fixed name. The Bastion service needs a fixed name. But all your other subnets, if you're naming them subnet 1, subnet 2, subnet 3, good luck at 2 o'clock at the night to find out which subnet is malfunctioning. Tell it, subnet databases, subnet VMs, you're one step ahead. Always secure your subnets with the network security group, meaning which traffic can come in, which traffic can go out. It's like a firewall, but it's not a firewall. It is not all the levels of the TCP stack that it's monitoring, but at least it's limiting all the networking stuff. Also secure each network interface card and private endpoint with its own network security group, creating a layered network. Again, which IP address can have access, which one can't. And please add a useful description to each network security group rule. Again, if one fails or is blocking traffic, it's nice to know which one it is. NSG rule 1, NSG rule 2 won't help you when you're trying to figure out what's happening. If at all possible, only use private endpoints. Make sure there's no connection directly to the angry internet. Because the angry internet is only trying to do one thing, that's get into your environment and do nasty stuff. A public endpoint, public IP address will be found and somebody will try to get in. And maybe somebody will make a configuration mistake, people will get in. All right, this is a bit of repetition because VPN and Bastion, virtual private network connections. These are the ones you need to get into your on-premises data environment. Secure access. There are other options available. This is the easiest one, and the one easiest to check. It's hard to set up. It will fail sometimes, but it's worth the effort. Again, make sure you allow the correct side ranges, also from the on-premises network, that not everything can get into your Azure environment. This is scary one. You can lose the Azure firewall if all traffic goes to the on-premises firewall, which means you can save about $1,000, whatever, each month. But you need to make sure all the traffic goes through your on-premises firewall. If there's anything open for another route, add a firewall. Usually there is, so this is a bit of a moot point, but it is possible. For the Bastion service, it's an easy way to get an RDP access to your virtual machine. Again, always secure these resources with the network security group. Encrypt everything. Databases have standard transparent database encryption enabled by default. That makes life easy. So your data should be encrypted. You can add your own certificate to stuff to add to your connection security, if you like to do so. Your disks are encrypted by default by Microsoft keys. Now, when you're looking at the Azure Advisor, it will come up and tell you your disks are not encrypted. They are, but they are encrypted with the Microsoft key. And technically, Microsoft can decrypt the data on your disks. If you bring your own key, which you should store in the Azure Key Vault, Microsoft can't decrypt your disks anymore. All right, time for some demos, or show you some code. Because I've been thinking about this, and trying to show you a lot of code running is a bit boring. So let's start with my small PowerShell stuff. I'm requesting a number of parameters, my login, my tenant, my subscription, and whether I want to plan or apply. Because Terraform has two settings. You can either plan your deployment, in which I'm going to say, what's in my tenant, what's in my code, compare them, and show me the differences. The other one is apply. The funny thing is, when I'm running apply, I'm getting a list of stuff that's in my code and what's in my tenant, but I'm getting a question. Do you want to continue? If you type yes, the deployment will continue and all the resources will be deployed. Thing is, stuff that's not in the code, but it is on the tenant, it's going to be removed. as long as the account on which you're doing this stuff has those permissions. If I'm running this from my local machine, I need to connect to my Azure account and use the AC login as well to get access on 2 levels. And then I'm going to say either plan or execute, apply. I'm always starting out with the main file. In the main file, I'm setting up my the providers I need. I'm needing some stuff on the Azure AD, the required version. I'm using my Azure RM stuff as a provider, and I'm telling it this is my tenant ID and this is my subscription ID. So I have control of where the stuff gets deployed. But it's not defined here. It started off with the word var, which is a shorthand for variable. Now, where do these variables come from? I'll get to that later. I'm doing some other stuff, and one of the things I'm doing here is create random passwords. This means a password gets generated for, in this case, my virtual machine and my database, 20 characters long, with special characters. It's never visible anywhere. It just gets created. When I'm starting to deploy stuff, you won't see it, but I can save it. I'm creating some management policies. So in this case, I've got a policy for my VM SKU, in other words, the VMs that are allowed within my tenant. This is just a policy rule, which means I need some parameters, list of allowed SKUs. Because the policy itself it's like a placeholder. And if my deployment is outside my list of SKUs, it's going to give a deny. You can also give it an audit, which means it gets registered within Azure, but the deployment will continue. Got my list of SKUs right here, but they're defined within the policy assignment. So within the assignment, I've got my list of all the standard VMs that I'm allowing in this case, small ones. Good luck trying to deploy a huge M-series VM. It won't work. Now I'm going to create my resource groups. So I've got one for my identity, connectivity, security, and data. I'm splitting the stuff out. Within one subscription, I've split stuff out. Again, you see a lot of variables. They're defined right here. I've got a variable for my tags. I've got a variable for my location. So I need to define these only once. I've got something about my management group ID. This is the one for my tenant ID, which of course is a bit hidden for you. And I've got one for my subscription ID. My resource group naming is defined right here. So if I need to change something, there's only one place I need to change it, and it will have effect in everything that's linking to these variables, which makes my life quite easy. Because for new deployment, all I need to do is change the variable file, and I'm done. I've got my network definition. Again, all relating to the other stuff. It's a bit of an abstraction of what you would normally do, but it makes sure that everything is dynamic and related to each other. So I've got my virtual network, I've got my subnets defined, and I've got my network security groups for my virtual network, for my VM network, for my database network. So now I'm defining my network security rules with my description. Network security group rule, allow gateway inbound. Description, allow the Azure Gateway Manager inbound. Might seem that I'm doing it twice, but there are a lot of instances where the name of the rule might be a bit cryptic. Fill in the description with a human description, and people understand what the rule is for. I want to have a SQL server. And this is when my random password is being used. My administrator login password, because in this instance I need to connect with it to the database with a SQL account, I need an admin password. SQL admin, administrator login with a password. You can do a lot of stuff in here, including setting the firewall, and I'm creating a private endpoint. I'm slowly building up my secure environment. Let's see if I'm supposed to see more. There we are. So I'm creating a database as well. I've got a name defined in my variables, my SKU name defined in my variables, my collation defined in my variables. My server ID is inherited from the deployment from the previous file, which means it's again all interconnected. This one, zone redundancy, I could have created a variable for that one as well. My lifecycle means that if somebody has the permissions to change the SKU of the database, it won't be overwritten by my deployment script. Which means Terraform will check, is our database? Yes. Is it the basic? Don't care. Is it hyperscale 24 cores? Good luck. I just want to know if the database is there. Don't care about the SKU. This will prevent some nasty surprises. I can create user-assigned identities as well. Identities to connect resources with each other. And finally, I'm creating a key vault. And I think I missed opening one file, because in this key vault, I'm going to save my secrets. The password I created in the main file will be saved in the key vault through this script. So in the end, I can get to it, because if I'm creating a 20-character password for my database, and I don't know the password, I still can't log in. But I can retrieve from my key vault. All right, this is the code I'm using. Now, let's see what happens when I click this. Of course, nothing. Something, focus. I only wanted it to play. All right, here we go. So I started my code, my PowerShell code. I'm entering my tenant ID and my subscription ID. Plan false, which means I'm going to do an apply. It's on true. I'm hitting enter, and at that point, Terraform is going to think of it. Got to do some stuff. I'm getting my local IP address, so you can always connect to all the secured resources. It's going to think a bit more. And if we are lucky, it's recorded once, so I know what happens. It's going to do a lot of stuff. It's going to check what's in the Azure tenant, what's in my code. So for instance, my Azure virtual machine will be created because it's got the green plus signs. Everything will be created because it was an empty subscription. It's going to create my virtual network. It's going to create my identity, my network security group, subnets, more subnets, more subnets. Keep scrolling. My Bastion subnet. I've got role assignments to be able to have access to my key vault. All my tags are being created in my resource group, identity resource group. So we're going to scroll down. And then it says only yes will be accepted to approve. Any other character, it will stop immediately. So let's enter yes. Again, it starts to think a bit. And now it should be starting to run. This can take some time because connections, stuff that needs to happen, and updates from the APIs that is actually running. So now you can see there's a lot of stuff that's being created. It's going to call out creating, sometimes finished. There's one caveat, if you will. When you're creating something like a key vault, the Azure APIs are not always aware that the key vault has actually been created. So when you start sending secrets to it, you may get an error. Solution for it, you can add sleeps. In my case, I'm usually adding a 5 to 10 minute sleep to give all the Azure APIs a chance to wake up and, oh, there's key vault. Oh, there's a firewall rule, so I can have access to the key vault. It can take time. And I know 10 minutes sounds like a long time, but it's for some reason it's necessary. Yes?
There's another way around that, because we hit that problem quite a lot, is to use a data resource, because sometimes it's an async issue. Terraform sends it off, Azure says, thank you, you can carry on, I've created it, and then behind the scene it creates. But if you use a data resource, it forces Terraform to wait to actually be able to read all the attributes back from creating it. So you don't have to then put like a very expensive 10-minute wait if it only takes 5 minutes to create it.
That's a good one. Thank you. Yes, question.
How do you manage the token? Because when you use a managed identity in DevOps, sometimes the token expires and it doesn't work when you try to create resources.
Good point. What I'm using?
Can you repeat the question? Oh.
What I'm using for the token, I'm using tokens with a lifespan of usually 5 days. When they expire, I need to create a new one. In my production code for my company, I've got an extra option flag to add the code to my deployment. So I can't deploy it if I'm not adding the token to my deployment code.
But after 5 days, you have like a stage in DevOps that you deployed it with the token, or how do you manage?
Let's take this one offline because it will take some time to explain how we set these things up. But let's do it offline. Ooh, more questions.
Between Bicep and Terraform, are there any standout differences that might sway you to one over the other?
I think it's mainly to do with personal preference, the kind of language you like to write. I'm coming from kind of C# background, and Terraform sort of kind of resembles that a little bit. If you're more into Java, you might lean a little bit more towards Bicep. The thing with Bicep is you need to keep up with all the API versions and all that stuff around that. So you need to do some extra work. But in the end, it's personal preference as well.
You are deploying networking infrastructure here. What if you have a team that wants to deploy their own resources but still connect to it? How would you manage that? Or
can you repeat the question? I couldn't hear it.
Let's say you have you're deploying network infrastructure here, but then you have a team that wants to deploy their own resources.
Yeah.
So then, how will you split this up? Because everything in your subscription gets deleted if it's not there.
Correct. There are two options. You can either import existing resources into another repository, or you just share the code you've used to deploy the network and let them build onto that. Those are the easiest ways to do it. There are other ways around it, but that gets complicated really fast and error prone as well. I've been there. Other questions? Got a few minutes left, and I just wanted to show you the result. Yes. So my resource groups got nicely created. Happy me. My tags are all nicely there. Again, happy me. I've got a connectivity resource group with my network interface cards, my network security groups, private endpoints, and my virtual network. So everything that has to do with network is exactly where I expected. I can also make sure people don't have access to it by making sure they haven't got reader on the highest level, but setting those permissions a little bit lower where they can't read this connectivity resource group. They don't need to know that there's a virtual network that has a network interface. Nothing they have to do there. My network interface card is a nicely private IP address. which makes life a little bit more secure. More importantly, it does not have a public IP address. So you can't reach it from the internet. If you want to connect to it, you either need a VPN connection or the Bastion service. I've got my network security group associated with my subnets. You can associate your network security group to one subnet, to more subnets, just the way you want to deploy your stuff and manage it all. My data resource group, there's an error. If you really, really want to have a pure deployment, because there's a private endpoint inside my data. Strictly, this private endpoint should have been in my connectivity resource group. I told you this is not production-grade code. I've got my networking set up for my SQL Server. I'm only allowing network access from selected networks, which means my local virtual network. I can also disable it, then nothing can connect to it, which makes the data really secure, but maybe a bit hard to reach. But I've created a virtual network rule that allows the local virtual network to connect to it. I've got my network, my user-assigned managed identity, nicely in my identity resource group. And in my security resource group, there's my key vault. And inside my key vault, I've got two secrets, my SQL admin password and my VM password. I did not have to do anything to do this. It was all managed by my code. And that's what I like about this. I still don't know what that password is. But I do know if I copy it and use it to enter my SQL server, it works. And I've got connection to my database. So now I've created quite a secure environment without having to click everything through in the portal. Thank you for joining my session. If you're going to fill out the session evaluation, the organizers of this event are going to donate to a charity, so please fill them out. And thank you so much for joining me.